Hey everyone, welcome back to Interview Breaker. Today we're diving into one of Swift's fundamental topics, the differences between structs and classes. If you've ever wondered how data is managed and manipulated in Swift, understanding structs and classes is essential. So let's break it down. First up, let's talk about value types and reference types. Structs are value types. When you assign a struct to a new variable or pass it to a function, you're actually creating a new copy of that data. This means each instance has its own copy, and changes to one don't affect the others. Structs are often allocated on the stack, which can boost performance for small, simple data types. Classes are reference types. Classes, on the other hand, are reference types. Assigning a class instance to a new variable or passing it to a function creates a new reference to the same instance. So, changes through one reference are visible to all others. Classes are allocated on the heap with references pointing to the memory location of the data. Inheritance is another key difference. Structs do not support inheritance. They can't inherit properties or methods from other structs, but can adopt protocols. This is more about composition than inheritance. Classes support inheritance, allowing subclasses to inherit and override properties and methods of their superclass. This enables polymorphism, where a base class reference can refer to subclass instances. How about mutability? Structs are immutable by default. If you declare a struct instance as a constant using let, all its properties are immutable. To modify properties within a method, you need to mark it with the mutating keyword. This promotes safety by encouraging immutability. Classes have mutable properties. Properties declared with var can be changed regardless of whether the instance is assigned to let or var. There's no need for a mutating keyword. Memory management differs as well. Structs don't participate in automatic reference counting since they're value types. Copying small structs is generally inexpensive, and classes are managed by automatic reference counting. Each instance has a reference count that increases or decreases as references are added or removed. This requires careful management to prevent memory leaks due to retain cycles. Identity is another distinguishing factor. Structs have no identity beyond their value. Two struct instances are equal if their data is equal, even if they're separate instances. And classes have a unique identity. Use 3 equal sign, an exclamation mark, and 2 equal sign to check if two references point to the same instance. When it comes to deinitialization, structs don't support deinitializers because they're value types and don't require cleanup upon deallocation. But classes can implement a deinit method to perform cleanup before the instance is deallocated. This is useful for releasing resources or observers. Initialization works differently too. Structs automatically receive a member-wise initializer if no custom initializers are defined, making it easier to create instances without explicitly defining initializers. And classes must define initializers to set up properties unless default values are provided. Subclasses can inherit or override initializers from their superclass. Comparing instances, Swift can automatically synthesize equatable and hashable conformance for structs if all their properties conform, making it easy to compare instances or use them in collections. For classes, you must manually implement equatable and hashable protocols. You need to decide whether equality is based on identity or value. Regarding typecasting, structs cannot downcast or upcast since they don't support inheritance. However, they can be cast to a protocol type. Classes can use as question mark, and as exclamation mark for casting between classes in an inheritance hierarchy, which introduces potential runtime errors if not used carefully. Both structs and classes can be extended and adopt protocols. Structs can be extended to add new functionality and adopt protocols to gain behavior. Classes support extensions and can adopt protocols and inherit from other classes, combining multiple forms of code reuse. Interoperability is crucial for some projects. Swift structs are not visible to Objective-C code. However, certain types like string, array, and dictionary are bridged to Objective-C counterparts. And classes, on the other hand, that inherit from NSObject can be used in Objective-C code. You can use at objc to expose Swift classes and members to Objective-C. So, when should you use each? Use structs. When representing simple immutable data like coordinates or sizes, you need each instance to be independent. You want to enhance thread safety. Use classes when modeling entities with shared, mutable state. You need inheritance and polymorphism, working with Objective-C code or frameworks. Performance matters. Small structs are allocated on the stack, which is faster, but copying large structs can be expensive. Classes. Instances are stored on the heap, which can be slower due to allocation and deallocation overhead. However, passing references avoids copying large amounts of data. Access control. Both support access modifiers like public, internal, file private, and private, allowing for fine-grained control over properties and methods. In concurrent environments, structs encourage immutability and avoid shared state, making them safer. Classes, shared instances require synchronization mechanisms to prevent race conditions. Functional programming paradigms, structs, align well with functional programming due to immutability and predictable behavior. Classes, mutable state can introduce side effects, making functional patterns harder to apply. Operators overloading, structs, can overload operators to define custom behavior, which is useful for mathematical types. Classes, less commonly use operator overloading, but it's still possible. Deinitialization and resource management. Structs must ensure resources are released appropriately since they lack deinitializers. Classes. Deinitializers allow for custom cleanup when an instance goes out of scope. Subscripts and nested types. Both can define subscripts for custom indexing and contain nested types within their scope. Now let's look at an example for understanding one more difference between classes and structs. As you can see, we defined struct point and class person and then creating instances of them trying to mutate them to look for the different behavior. In this example, assigning point to point 2 creates a copy, so changing point 2 doesn't affect point 1. Assigning person to person 2 creates a new reference to the same instance, so changing person2.name also changes person1.name. Understanding the differences between structs and classes in Swift is vital for writing efficient, safe, and maintainable code. Here's what we've learned. Structs are value types, promote immutability, and are ideal for simple data structures. Classes are reference types, support inheritance, and are better suited for complex data models with shared state. By choosing the appropriate type based on your needs, you can optimize performance, enhance concurrency, and design better APIs. Thank you for joining me on this deep dive into structs and classes in Swift. If you found this video helpful, you know exactly who would benefit from it, so go ahead and share it with them. Don't forget to hit that subscribe button and give this video a thumbs up. Good luck on your coding journey, and I'll see you in the next video.